Welcome to this explainer. Today, we're diving into a totally counterintuitive medical reality about the human spine. It's a fascinating process, a real plot twist, honestly, that might just save you or someone you love from a trip to the operating table. So let's jump right in by asking a question that terrifies pretty much anyone who's ever felt a sharp shooting twinge in their lower back. Do you think a herniated disc always requires surgery? For decades, the cultural assumption has basically been that if you blow out a disc in your back, you're destined for the scalpel. But as we're going to see today through the latest medical literature, that assumption is being radically rewritten. To really wrap our heads around the scale of this, we've got to look at the numbers. A staggering 80% of all people will experience lower back pain at some point in their lifetime. Think about that, 8 out of 10 of us. It makes this an incredibly relatable and widespread issue, and it's actually one of the absolute most common reasons people even visit a doctor. And man, this pain isn't just physically debilitating, it is financially crushing. Lower back pain leads to over $100 billion in US healthcare costs every single year. We're talking missed work, expensive imaging, and months of long rehabilitation. Now, obviously, back pain has a lot of different causes, but for about 1 to 3% of the population every year, usually folks age 30 to 50, the specific villain behind this agony is a lumbar disc herniation, or LDH. This is the prime suspect when you get that intense pain radiating from your lower back right down through your glutes and into your legs. To really understand what LDH actually is, I want you to picture your intervertebral disc like a jelly donut. Seriously. You have the nucleus pulposus, that's the watery, highly hydrated jelly right in the center. And wrapping tightly around it is the annulus fibrosus, which is the doughy, fibrous outer shell that keeps all that jelly safely contained inside. So herniation happens when that inner jelly pushes out through a tear in the outer shell. You can clearly see how the displaced jelly just squishes right into the spinal canal. When it does that, it mechanically compresses the traversing nerves. That pressure, along with all the resulting inflammation, is exactly what causes that severe radicular pain, numbness, or even weakness in your legs. Okay, so the jelly is out, it's crushing a nerve, and you are in total agony. Just when you might think invasive surgery is literally the only way to remove that pressure, the medical literature reveals a massive plot twist. Your body actually has its own built-in self-healing mechanism called spontaneous resorption. Yep, you heard that right. The herniated fragment can actually disappear completely on its own. And hey, you don't just have to take my word for it. Check out these before and after scans. On the left, we've got a massive L5/S1 disc herniation. Just look at that giant dark mass pressing right into the spinal canal. Now look at the scan on the right. Just 5 months later, that massive herniated tissue has spontaneously and completely vanished. The canal is completely clear, and the craziest part? This was achieved with only conservative treatment. No surgery whatsoever. Seeing those photos usually leaves people completely stunned. I mean, you're probably wondering, how on earth does a giant chunk of displaced spinal disc simply vanish without a surgeon's scalpel to cut it out? It almost sounds like magic, doesn't it? But it's actually an incredibly elegant evolutionary mechanism. It all comes down to a brilliant 4-step biological sequence. First, the disc ruptures and that water-rich jelly leaks out. Second, once it hits the epidural space, it immediately starts to dehydrate and shrink. Third, and this is absolutely crucial, because the inside of your disc is normally totally isolated from your immune system, your body actually treats the sleek jelly as a foreign invader. It triggers a massive autoimmune response. Finally, your immune system deploys special cells called macrophages to literally eat the herniated fragment, kind of like a microscopic game of Pac-Man. But wait, there is a slight logistical hiccup for your body here. How exactly does it get those immune cells to the injury site when spinal discs don't normally have a blood supply? Well, the answer is neovascularization. To get those Pac-Man macrophages to their target, your body literally builds brand new blood vessels right at the edge of the herniation. It constructs its own microscopic highways specifically to deliver the cleanup crew. And the coolest part is that doctors can actually see this highway construction happening in real time. If a scan shows what radiologists call a bullseye sign, which is this bright ring of enhancement around the protruding disc, it proves those new blood vessels have successfully arrived. It's basically a giant green light that the inflammatory healing process has kicked off, and the disc is highly likely to reabsorb naturally. So let's move to a really fascinating comparison that sets up a highly counterintuitive paradox about predicting your recovery. we're going to compare a minor contained bulging disc with a massive sequestrated disc. A sequestrated disc is basically a piece of jelly that is completely broken off and is just free floating in the spinal canal. Between the two, which one do you think heals better without surgery? Get this, the worse the herniation looks, the better it heals. Seriously, look at these regression rates. A massive free-floating piece of sequestered disc has a phenomenal 96% chance of shrinking away naturally. Meanwhile, a tiny contained bulge only has a 13% chance. Why on earth is that? Because those massive, uncontained ruptures trigger a much stronger, much more aggressive immune response. Your body notices the huge messes way faster than the small ones. Now, to be totally clear, this magical self-healing isn't guaranteed for absolutely everyone. There are some biological roadblocks. For instance, if a scan shows modic changes, which are variations in the bone marrow of your vertebrae, or if the herniated piece has a high amount of tough cartilage instead of just watery jelly, the blood vessel growth can get inhibited, which stalls the healing. And critically, if anyone experiences progressive neurological dysfunction, like losing bladder control or severe muscle weakness, that is a massive red flag. That's a medical emergency that bypasses waiting and requires immediate surgical intervention. But, and this is a huge but, for the vast majority of patients who don't have those severe red flags, the data provides immense hope. Research consistently shows that 60 to 90% of people will experience significant improvement using only conservative therapies. That means relying on rest, specialized physical therapy, and targeted anti-inflammatory meds to manage the pain, all while giving the body that crucial 3 to 6 month window to literally eat the problem away. So I want to leave you with this final, provocative thought to ponder the next time you or someone you know gets a scary scan result showing a blown disc. If our bodies have literally evolved to orchestrate this incredible disappearing act entirely on their own, building brand new blood vessels, deploying cells to consume the damage, why are we so incredibly quick to assume a surgical scalpel is the only fix? Sometimes the absolute most powerful medicine is just giving our biology the time and the right environment to do exactly what it was built to do. Thanks so much for joining me for this explainer, and I really hope this totally changes how you view the incredible resilience of the human spine.